Hello friends, in this video we will learn convolution with impulse input. Let us begin. To start with convolution with impulse input, we'll go through some fundamentals with respect to impulse. We know that an impulse input del of n is always 1 at n equal to 0 and it is always 0 when n is not equal to 0. Graphically, it can be shown like this. So on x-axis we have n. At n equal to 0, we have an amplitude equal to 1. Or in sequence form, it can be written as del of n is equal to 0, 1, 0. At n equal to 0, it is having an amplitude equal to 1. In fact, by summation property, we can say that summation when n is moving from minus infinity to plus infinity, del of n is always 1. Am I right? For example, if we talk about del of n minus 1, right? Then how do we plot del of n minus 1? Again, on x-axis we have n, but this time impulse signal is present at 1, that is n equal to 1. So at n equal to 1, we have an impulse signal, right? Or I can say del of n minus 1 is always 1 only for n equal to 1, and when n is not equal to 1, it is always 0. In fact, by summation property, that is when n is changed from minus infinity to plus infinity, even del of n minus 1 is also 1. In general, in any form, that is a time shifting form, when n is moved from minus infinity to infinity, del of n, whether it is plus or minus n naught, it is always equal to 1. In fact, this is called as a summation property for an impulse input. Also, we have seen a multiplication property. So according to multiplication property, we have seen that whenever x of n is multiplied with del of n, it is always x of 0 dot del of n, because del of n is present only at n equal to 0. If such signal gets multiplied with x of n, then definitely x of n gets sampled at n equal to 0. Similarly, if x of n gets multiplied with del of n minus n naught, then we know that this impulse signal is present at n equal to n naught. So I can say that it is x of n naught dot del of n minus n naught. If x of n gets multiplied with del of n plus n naught, then this is an impulse signal present at n equal to minus n naught. So your signal x of n gets sampled at x equal to minus n naught dot del of n plus n naught. So this product property, that is multiplication property, also we have seen. Once you are comfortable with summation property as well as multiplication property, then convolution becomes quite easier for you. So we know in general, suppose y of n is equal to x of n when convolved with h of n, it is given as summation k equal to minus infinity to plus infinity x of k h of n minus k. So this is the formula for discrete time convolution. Let us assume I want to perform this operation, that is x of n convolved with del of n. In that case, now you can compare with this equation 1. So in the place of h of n, what we have is del of n, that is unit impulse signal. So now I can write, let's say this is equal to y of n, then y of n can be given as summation k equal to minus infinity to infinity x of k dot del of n minus k. Is that right? Or I can rewrite this, k equal to minus infinity to plus infinity x of k dot del of minus k plus n. You know that your main variable is k and not n, so I can make this as coefficient free by taking minus 1 out. What remains inside is k minus n. Is that right? Or we know that the unit impulse signal or any impulse signal is an even signal, so this time reversal doesn't matter. So this is equivalent to del of k minus n only, right? Dot x of k, and summation is from k equal to minus infinity to plus infinity, and this whole is equal to what? Y of n. So now I can use a product property here. So you have to use a product property. So observe this del function. This del function is present at k equal to positive n. So I can use a product property and I can rewrite this y of n equal to summation k equal to minus infinity to plus infinity. I can write x of n dot del of k minus n. Is that right? Now if you observe carefully, this summation belongs to variable k because k is changed from minus infinity to plus infinity, and as you can see now this is x of n, so it is independent of k. If it is independent of k, x of n can be taken out of the summation. So I can now rewrite y of n as x of n, and in the summation, when k is changed from minus infinity to plus infinity, del of k minus n. Is that right? And on the previous slide only we have seen the summation property. When it comes to impulse function, irrespective at what time interval it does exist, summation is always unity. Is that right? So what remains? So it is simply y of n is equal to x of n. So I can straight away say that output is simply input if the impulse response is del of n. Am I right? Let me come to the conclusion. When x of n gets convolved with del of n, it is always x of n itself, right? And this is actually true even in continuous time signal also. That is, in continuous time system, what we have is x of t and not x of n, right? When it gets convolved with del of t, this is x of t only. So as you can see, whether it is in case of discrete time signal or whether it is in case of continuous time signal, when input gets convolved with an impulse, then input remains same. Is that right? So when x of n gets convolved with del of n, output is x of n. X of t when gets convolved with del of t, output is x of t in case of continuous time signal. Now let's see the time shifting property in convolution. This property is very important. If you understand this time shifting property, then it is easy for you to understand the problems based on this concept. Let us begin. If we say that x of t when convolved with h of t, it's simply y of t. Is that right? So where x of t is an input, h of t is an impulse response, and y of t is what? It is obviously output. In that case, by using time shifting property, if it is, let's say, x of t minus t1, let's say it is getting convolved with h of t minus t2, then output can be written as y of t minus t1 minus t2. Or I'll just make it quite simpler. Let me just take, if x of t convolve with h of t, it's simply y of t. Then let's say x of t minus t naught convolve with h of t, it is simply y of t minus t naught. So what is happening, I'll tell you. When x of t convolve with h of t is y of t, then x of t minus t naught convolve with h of t, it is y of t minus t naught. So basically I can write it like this. So I'll read this and I'll make you understand what I have written. Amount of shift at output is always equal to summation of shifts at input and impulse response. Okay, let us see. As you can see, when x of t, I'm talking about this, when x of t convolve with h of t is equal to y of t, then x of t minus t naught convolve with h of t. Now see to it, what is the shift in case of input? Then you can answer, it is minus t naught. See, in case of input, the shift is minus t naught. In case of h of t, that is impulse response, how much is the shift? Then we can say there is no shift. There is no shift, right? Then in the output, you have to do summation of shifts at input and impulse response. As you can see, total shift in the input is minus t naught. There is absolutely no shift at impulse response. Then in the output, okay, the amount of shift will be equal to summation of shifts at input and shifts in impulse response. And therefore, resulting shift in the output is minus t naught. In this case, as you can see, at input, the shift is minus t1 and impulse response it is minus t2. Then in the output, it is summation of both. So if x of t convolve with h of t is y of t, then x of t minus t1 shift is minus t1. Here shift is minus t2. Then in the output, we get total shift which is summation of both, that is minus t1 plus of minus t2. So it becomes minus t1 minus t2. So I'm sure now you are quite comfortable with this time shifting property of the convolution. So we'll see more example. For example, we have x of t, let's say convolve with h of t plus 1, then output is x of t plus 1. Is that right? As you can see, there is no shift. There is a shift of plus 1. Then in the output, okay, I supposed to say y in place of x. Is that right? So at input there is no shift. At impulse response there is a shift of plus 1. Total shift is plus 1 that occurs at output. Let's say if x of t convolve with h of t results into y of t. This is what we know already. Then x of t minus 1, let's say it gets convolved with h of t plus 1, then still it is equal to y of t. Why so? Because total shift at input it is minus 1, total shift at impulse response it is plus 1, then amount of shift at output is equal to summation of shifts at input and output. So at input it is minus 1, at impulse response it is plus 1, summation becomes 0. So there is again no shift at output. Or else I can write like this. If x of t plus 3, let's say convolve with h of t minus 4, I'm sure now you can recognize how much shift occurs at output. So here shift is plus 3, here shift is minus 4, summation becomes minus 1. So it is y of t minus 1. So it is that simple, right? So let us understand what is meant by a delay system and the advanced system. So I'll name this very first system as delay by t naught system. Let us understand what is the meaning of delay by t naught system. Okay, only one thing I'll just correct over here. This is not a discrete time system now, so I can write this as x of t and this is simply y of t now. Fine. So delay by t naught system means if the input is applied as x of t, okay, then it is expected that delay takes place at input and output becomes x of t minus t naught. I hope you got my point. Let us see what we have done over here. We know that if this is a system, then inside the system whatever written is always considered to be an impulse response. And we know that if this is y of t, if this is h of t, and this is x of t, then we know what is the relation between them. We write y of t is equal to input x of t convolved with its impulse response. But impulse response is what? It is del of t minus t naught. Is that right? So we have already studied, if, tell me, if x of t convolves with del of t, we know that it remains as x of t only. In that case, now you can write y of t equal to. So when x of t convolved with del of t, it remains x of t. Then x of t convolved with del of t minus t naught, it remains as x of t minus t naught. Is that right? So now we can conclude something. As you can see, what is an input? It is x of t. What is the output? It is y of t, right? But then the value of y of t is what? A delayed version of input. And by how much amount it is getting delayed? By t naught. So whenever you want delay by t naught system, your impulse response should be del of t minus t naught. I repeat, whenever you want delay by t naught system, that is, if you want to delay your input by t naught, then your impulse response must be del of t minus t naught. Similarly, in the second category, you can see here, this is another system. I would name this system as advanced by t naught system. So again, I'll change over here as x of t, and I'll change y of n to y of t, because this refers to continuous time signal and not discrete time. So we know that this is input, this is output of the system, and whatever we write inside the system or inside the box or inside the block, it is always an impulse response. So by relating them, y of t is always x of t convolved with del of t plus t naught in this case. Am I right? So we know that if x of t convolved with del of t is x of t itself, then x of t convolved with del of t plus t naught by using a time shift property, I can write y of t as x of t plus t naught. So now you compare output with respect to input. Input is x of t and output is x of t plus t naught. So can I say that output is advanced version of x of t? And how much is the advancement? You can see advance is done with positive t naught. So now we can come to the conclusion. Whenever you want to advance your input by t naught, then your impulse response should be del of t plus t naught. So now let me just summarize it. Whenever impulse response is del of t, output and inputs are always same, because we know that x of t when gets convolved with del of t, output is x of t only. Is that right? So once again, when the impulse response is del of t, output and input are same. Whenever the impulse response is del of t minus t naught, output is delayed version of input by t naught. Whenever impulse response is del of t plus t naught, then output is advanced version of x of t, and advancement is by positive t naught. So this is something, if you know in advance, then it is possible to solve the problem within a short time. Let us begin with an example. Consider a discrete time LTI system with input x of n as del of n plus del of n minus 1. So please note that this whole thing is your input. Next, impulse response h of n. So this whole thing, this is your impulse response. And what they are asking you, output of the system. Okay, and they have given you 4 options. GATE 2008 problem it is. Let us see how we can deal with this. Let us relate them with standard relation. Y of n is always x of n convolved with h of n, or I can write y of n. Let us substitute your x of n. X of n is what? It is del of n plus del of n minus 1 is getting convolved with your h of n. What is your h of n? It is del of n minus del of n minus 1. Now, the way you multiply, in a similar way, you will convolve. That is, first of all, by del of n, you will convolve this whole term, and then by del of n minus 1, again you will be convolving the same bracket. That is, you can write it like this: del of n is convolved with del of n minus del of n minus 1 plus, because we have a plus sign here. Then second term, del of n minus 1 gets convolved with again second bracket, which is del of n minus del of n minus 1. So let me just expand. Now del of n gets convolved with this also and this also. So I can write del of n convolved with del of n minus del of n convolved with del of n minus 1. So let us solve this now. Plus del of n minus 1 is getting convolved with first term, which is del of n, and again because of the minus sign I can keep minus over here. So now this part gets convolved with second. So del of n minus 1 gets convolved with del of n minus 1, right? Then this whole equal to, see, you shouldn't forget your basics. We know that if x of n convolved with del of n is x of n itself, am I right? So what if this x of n itself happens to be del of n? So del of n convolves with del of n will become, of course, del of n. So using that logic, del of n convolved with del of n, it's simply del of n, right? Then now we know that del of n convolved with del of n, if happens to be del of n, then del of n convolved with del of n minus 1 will be minus of del of n minus 1. That is, total shift in the output is summation of shift in input as well as shift in impulse response. Plus, because we have plus sign here. So I'm sure now you will recognize what output can be. When del of n minus 1 convolved with del of n, it is simply del of n minus 1. Then we have negative sign here. Del of n minus 1 into del of n minus 1 is obviously del of n minus 2, because minus 1 will give you minus 2. If you observe carefully, this minus and this plus gets cancelled. Now I can write final y of n, right? Whatever remaining, that is del of n minus del of n minus 2. Is that right? Now if you check it carefully, option A is the correct option, right? So it is quite easy. Okay, so you can refer this method, or I have another approach to tell you. So let us discuss next approach. So what is the next method? For that, what I'll do is x of n. Okay, I'll just copy x of n given, which is del of n plus del of n minus 1. Is that right? Now this is input given in terms of shifted impulses, right? Shifted impulses, because this is an impulse and this is a shifted impulse. So ask a question to yourself. When I say del of n, it is an impulse present at n equal to, of course, 0. And this is the impulse present at n equal to positive 1. So in fact, I can write my x of n in the form of sequence, that is 1 comma 1. You can show an arrow mark here. See how it has come. It's very simple. Let me just draw an axis here. Now first of all, draw del of n. Where del of n is present, of course it is present at 0, having an amplitude equal to 1. Then the next impulse is present at n equal to positive 1, having, again, see the coefficient is 1, and it is 1, right? So this is the discrete information and this is the sequence information. So x of n is ready with me. Let me just try to express my h of n also. H of n was del of n minus del of n minus 1 Graphically I can represent it like this. Again, axis is n. We know that the first del of n is present at n equal to 0, will have an amplitude equal to +1, and second impulse is present at n equal to +1 because it is del of n minus 1. Of course it is present at 1. But see the coefficient is -1. It means it will have an amplitude equal to -1. So in the sequence form I can write it like this: 1 comma -1, and at n equal to 0 we have an arrow mark here. This is h of n, right? So we have x of n and h of n with us in the form of sequence. So I'm talking about this. This is your x of n and this is your h of n. So tell me, if x of n and h of n in the sequence form is known to me, I'll be using a tabular method in order to get y of n. It's very easy. So let me write my x of n as 1 comma 1 and h of n is 1 minus 1. So just multiply 1 1 minus 1 minus 1. Let us have diagonals now. So what y of n you supposed to get here? First element is 1. We know that arrow marks are here. Naturally you'll get first element here. Minus 1 plus 1, it is 0 comma remaining is -1, right? See, 3 diagonals means 3 elements would be there. Now this y of n, if expressed in the form of sequence, then it can be expressed in the form of impulses. Am I right? Now of course you know that this is present at n equal to 0, this is present at n equal to 1, and this is present at n equal to +2. Then we know that whenever impulse present at n equal to 0, we represent this as del of n. And what is the coefficient? Coefficient is 1. Okay, so there is no need to write coefficient 1, but now I have written it. So we know that at n equal to 1, there is nothing present. Okay, it means there is no impulse present at n equal to 1. But then something is present at n equal to 2. So I can represent this as del of n minus 2. Right? And see what is the magnitude? Okay, instead of magnitude, we'll call it as an amplitude. Amplitude is -1, so I can say coefficient is -1. So finally you can write it like this: del of n minus del of n minus 2, and this is simply your y of n, which is your option A, right? So let's move to the next problem. Result of the convolution x of minus t when gets convolved with del of minus t naught is, and they have given you various options. Let's see. So we'll use a basic property. When x of t gets convolved with del of t, output is what? Of course it is x of t itself, am I right? So let's say x of minus t when gets convolved with del of minus t naught. Okay, so now we need to just simplify first of all this function. So x of minus t, I'll keep it as it is. When gets convolved with del of, okay, to make t coefficient free, I'll take -1 out. Is that right? We know that we go from left to right approach. Delta signal is always an even signal, so time reversal, it doesn't matter. So I can represent it like this: x of minus t convolved with del of simply t plus t naught. Is that right? So now this is an impulse present at t equal to what? Minus t naught. So now I can write it like this. Now this is equal to x of, so t should be replaced with t plus t naught. So we basically replace t with t plus t naught. Therefore we already had a minus sign here, and t is replaced with t plus t naught. So now this is equal to x of minus t minus t naught. As you can see, it is option D. So once again I'll tell you what we have done. Okay, see the first step. This is the first step. You know how do we solve this? X of t when convolved with del of t, it is x of t itself. Now what I've done, I have written a question here, that is x of minus t when gets convolved with del of minus t naught. So x of minus t, I have kept it as it is. Del of. To make t coefficient free, I have taken minus 1 out. What remains inside? T plus t naught. We know that time reversal doesn't affect your delta function, so it remains as del of t plus t naught. Whenever we convolve with an impulse signal, you have to see what is the argument of the impulse signal. I repeat, whenever you are convolving any signal with a del function, you have to see what is the argument of del function. Argument is something which is written inside the parenthesis. Remember, these brackets are called as a parenthesis. So what was written inside it? It was t plus t naught. In that case, always replace t, okay, with argument of del function, which is t plus t naught. So what we have done, in the place of t, we have replaced with t plus t naught. In effect, it has become x of. We already had negative sign, so that negative sign I have taken, and t is replaced with t plus t naught. So it is x of minus t minus t naught, which is option D. I can tell you another method also. See method 2. So I guess with method 2 you would be more comfortable with. So what we had is x of minus t convolved with del of minus t minus t naught. I'm sure now you must be getting confused with this negative sign. So you can do one thing. These are just variables, right? So just replace minus t with some other letter, let's say positive k. So I'm just replacing, because we are not comfortable with negative sign, I'm replacing minus t with plus k, right? So wherever there is minus t, just replace with k. So now this will become x of k convolved with del of k minus t naught. Very simple now. So now this can be written as, okay, now this is the del function present at t equal to positive t naught, or I can write x of k into del of k minus t naught as x of k minus t naught. But we know that what is the value of k? The value of k was minus t. Replace k with minus t, and what we had here? Minus t. And see, it is option D. So option D is the correct option. So I'm sure you must be comfortable with method 2. So whatever method that you are doing, okay, you should be comfortable with. So with this, now we have completed problems which are based on convolution with impulse input. Okay, so we'll be solving more problems. We'll be discussing more concepts. Still, there is much more convolution that we need to discuss. Thank you.